This session provides some general tips and tricks on the general use of GeoStudio 2007. GeoStudio has many features not directly related to the main solver calculations. Features to aid with, for example, adding clarity to the problem definition and presentation of the results, like, for example, labeling and sketch lines or construction lines, creating properly scaled engineering drawings, importing data from other sources, inspecting the analysis results details, and finally reporting the problem definition and results in your reports. To start with, then, we will talk about set page. Set page allows you to define the size of the paper you want to eventually use to print and present the analysis drawing. Usually this is governed by how you wish to present the analysis results to somebody else, usually as presentation in a report. Obviously, the most common paper sizes are letter size, 8.5 by 11, which we usually in engineering use as in landscape mode at 11 by 8.5, at 11 inches by 8.5 inches, or in the metric system we commonly use the A4 paper size, and in landscape mode it is always 297 by 210 millimeters. Now these are common paper sizes for reporting, but often it is convenient to use a larger paper size, and very common engineering drawing sizes for reports are 11 by 17 or 17 inches by 11 inches in landscape mode, or we use the A3 paper size, which is 420 millimeters wide by 297 millimeters high. Using a larger paper size is highly recommended because a page size affects the drawing scale. The smaller the page size, the higher the required scale. The higher the page size, the lower the required scale. And the objective you should strive for is to work at as small a scale as possible. The smaller the scale, the more accurate the computer screen interaction. Ultimately, it reduces down to how much does one pixel on the monitor represent, because this is the level of accuracy that we can work with is pixels, and so to work at smaller scales allows more accurate interaction with the computer screen. GeoStudio also allows you to work at a true engineering scaled drawing. By definition, what this means is, for example, if we say the scale is 1 to 100, it means that 100 millimeters on paper is 100 millimeters in the field, or 0.1 meters in the field. 1 centimeter on paper is 100 centimeters, or 1 meter in the field. 1 inch on paper is 100 inches in the field, or 8.33 feet in the field. So we describe the scale as a ratio of 1 to 100, 1 to 200, and so forth, and as we will see, we highly recommend that you use good numbers like 100, 200, 150 rather than a decimal number. It makes it very difficult to interpret the scale if it is some fraction of a number. To illustrate the GeoStudio implementation, the idea is that a drawing printed at a zoom factor of 100% a zoom factor of 100% will be printed at a true scale. In this particular case here, we have set a scale in this example of 1 to 100. That means that 1 centimeter on paper is equal to 100 centimeters in the field, or 1 meter in the field. We can see here that we have on our physical scale 20 centimeters. The 20 centimeters represents from 0 to 20 meters in the field, and that each of these tick marks represents 2 meters, which in turn in the physical dimension is 2 centimeters, or yes, 2 centimeters. I recognize that we don't use a true scale all that much anymore in the computer-aided drafting world. However, the demonstration is to show here the GeoStudio implementation and to demonstrate that it is possible to produce a printed drawing of your analysis at a true engineering scale should you find that desirable in your reporting. The guideline is that all objects on the drawing should be readily visible and legible when the drawing is viewed at a zoom factor of 100%. Stated another way, we should try and select a scale such that all the objects on the drawing are readily visible and legible when the drawing is viewed at 100%. So when we click on the zoom page icon, all of the objects should nicely fit onto the page. That is the intended objective. There is also some control over the positioning of the coordinate system on the page, and this is done by specifying min and max values. The minimum value X and Y fall on the lower left corner of the paper size that you have selected, and the maximum XY falls on the upper right corner of the paper size that you have selected at a particular specified scale. We're going to demonstrate this a little bit more in just a few seconds. Let us then open up GeoStudio and demonstrate how to set the scale and how to select the paper size and then put a scaled axis on the paper and position it on the paper. Let us assume that we have an engineering analysis where we want the X to go from at least 0 to 150 meters and in the Y direction to go from 0 to 50 meters, and that we are going to decide to use a paper size of 17 by 11 inches. Going then to GeoStudio and creating a new analysis. In this particular case, I have selected a slope W analysis, but any analysis can be used for this portion of the illustration. So the first thing we should do is say set page, and we decided in this case to make it 17 inches wide and 11 inches high. If we now click on the zoom page icon, it gives us a outline of the entire page that we are going to produce our drawing on. The next stage is to set the scale. Under the command set units and scale, we'll go then to set units and scale. We are going to use the metric units, and we will uncheck this option here.